Thanks, Sammy, and thanks everyone for joining. Really appreciate everyone taking the hour to join today's webinar. And the topic will be about accelerating your cloud data migration ran between ourselves, DBT Labs and Infinite Lambda. So maybe we'll start off with introducing ourselves. So hello to everyone on the call. My name is Mike. I'm a senior solutions architect here in DBT Labs, primarily covering UK enterprise, but also working with companies across EMEA, basically helping them from a technical perspective as they evaluate DBT Cloud, which is normally paired with, which is often paired with a migration to a more modern data stack generally, and that can include your data warehouse, of course. Before here, I did this job with Google for a few years, helping people move to BigQuery. And before that, I was a data analytics consultant for one of the big four for a few years. It's been around migration projects for quite a while. And I'll pass to Sammy.
Thanks, Mike. Hi, everyone. I'm Sammy, and I'm a data engineering technical lead here at Infinite Lambda. I've been with Infinite Lambda for around about 8 months, and here I look after technical implementation of data platforms, with the modern data stack. So I have got 4 years of experience working with DBT, both at consultancies and product company. And as a matter of fact, my 2 previous projects were DBT migrations. So I'm hoping to share some of the things that I have learned with you today, and hoping that it will be useful for you guys.
Absolutely. So we're going to maybe go through the agenda, break this up into a couple of different parts of like, what does a migration project generally look like, right? So we're going to start off with just a general migration overview. What does it look like? Why one might do it? And then the different steps as we see it in a migration process. And when we're going to deep dive on 2 of those areas, I will walk through the building of the business case, right? The less technical stuff, but the hurdles that one needs to get over in this process, which is how do you, usually a technical audience is well aware of the value of a migration. And then how do you effectively communicate the value of that communication to a, still a technical audience, but a less technical audience, people who hold budget in the technology sector of your business. How do you communicate the value of that migration process and why the company should be interested in that? And then Sammy will be diving more into practice, more into like, okay, now that we've started the migration process, what are things to look out for? How can we basically try and speed up as much as humanly possible that migration process, both to DBT, but then also to the warehouse itself, usually from a legacy stack. Housekeeping, we will of course save time for questions at the end, but I would encourage you to pop your questions into the questions area of Livestorm here. You should be able to pop your questions in there, and either myself or Sammy will either type back, or maybe we can bring it up at the end. We'll figure it out as we go. Okay. So maybe let's start off with just orienting. When people are doing a migration, what are they generally talking about? What are they moving from? And what are they generally moving to? Okay, so generally, and I think Sammy will agree with this, when you're looking at a legacy stack, you're looking at 2 things. You're looking at the technology, but you're also looking at the methodology of how one does their transformation today, right? Generally, people are doing ETL when they're coming from a legacy stack, right? And that's where they extract their data. They do the vast bulk of their transformation before they load it into the warehouse. That's the key thing here. And then they load it into the warehouse in a transformed state. So what you have landing in the warehouse is already transformed data. That will generally sit on top of, on-prem architecture, your Postgres's, your SQL servers, your MS SQLs, Oracles, whatever it might be. And then end users would have consumed from there, right? Now, there are some inherent issues in that around scaling, around cost of growth, but then also around access from the business to data generally, right? If you think about these users over here and how they access it generally via dashboarding, being consumed from the data warehouse. And if anything goes wrong with that, or if they have generally any question or any request, it's very difficult for them to get any context into that because everything that's important happened before the warehouse, right? Everything that's important happened usually in the data engineering org before the data actually hit the warehouse. So they'll only ever see the data from that's in their dashboards reflected in the warehouse, nothing extra, no lineage, no kind of troubleshooting, no kind of testing, whatever it might be. Okay, that's why as a whole, when we see a migration process, we also normally see a methodology change. And that's a move from ETL to ELT, right? And as the reversal in letters would suggest, that's where you do the extract and load before the transform, and then you do the vast bulk of your transformation on top of your new data warehouse, which is normally cloud hosted, a Snowflake, a BigQuery, a Databricks, a Redshift, whatever it might be. And that is where DBT sits, right? On top of your warehouse, managing and orchestrating all of that transformation. So why am I saying all this? It's just important to note that we're not just talking about technology change. There's also methodology change within that as well. And the benefits of that methodology change often are actually why one does the migration in the first place, right? It would be very hard to do ELT in this landscape, but in a newer landscape, ELT becomes possible, and there's inherent benefits to moving to ELT. Okay, that's a quick summation of the migration overview, but I guess then that leads naturally to why migrate at all. There's a lot of reasons. I'm sure if you're on this call, you probably are know of a couple already or have already made that case. But there's numerous, right? Improved performance around scalability and flexibility. Often legacy architecture can be quite costly to maintain and certainly quite costly to scale. You often start to see real cost when you start to get to real data volumes and real frequency of pipelines for real-time use cases. So that leads naturally to cost efficiencies, reduced operational overhead, greater productivity and collaboration among data and engineering teams. And what we mean by that is, in a world where one does ELT, that means that a different audience can get involved in transformation, right? That means we can now start to open this up to a more SQL-orientated audience rather than maybe your data engineering team. And if that frees up data engineering time, what's the added benefit of that? Can we ship changes faster? Can we get them focused on higher value work rather than maintaining pipelines and maintaining transformations, which might have been their modus operandi to date? One I personally see more and more is AI enablement, and I'm sure everyone has seen some kind of AI docket cross their desk or an idea come up in a meeting about, oh, can we use AI for that? And that's super exciting, and we should definitely encourage that. But I think most data practitioners are aware that to enable those AI workflows, you've got to have good, clean data accessible fast. And that is difficult to achieve on a legacy architecture. So then the focus becomes, how do we set up our infrastructure to enable those AI workloads that have got so much attention right now, especially amongst C-suite management, who are usually the people you're trying to convince to do this in the first place. Okay, and better visibility and governance. But what we found, and when we did a survey recently in an ebook called Building the Business Case, which I can share in the chat after this, was despite major benefits, more than 1/4 of DBT users surveyed reported facing some initial resistance to this way of working due to legacy tech debt, competing priorities, and inability to secure budget and buy-in, right? So then the question becomes, how do we secure that budget and buy-in? So we see a migration as a 4-step process. You can break these into several sub-steps, but this is just a high level, right? And what I'm going to talk about right now is a bit around building the business case, and then I'll touch lightly on discovery and scoping for that migration process. And then Sami is going to go a little bit more in depth. He's going to talk about things that you're going to be thinking about during the pilot, and of course, things that you're going to be thinking about during the actual migration itself, and how to practically do those things. So if anyone is interested in looking at code, that's the bit that you'll be looking forward to here. Okay. So building the business case. I think we've gone through a lot of the reasons why people might migrate, and I don't think I need to probably convince the people on this call as to the benefits of a migration project, both hard cost saving and then soft benefit as regards, moving from siloed workflows to collaboration, moving from lack of governance to a trusted data. But then when one tries to make the case to maybe more senior management, it can often feel like this, right? How do we do it for as cheap as possible? So what we, I think, as data practitioners need to be good at is quantifying the value to the business of that migration. So the way we see it, there's 7 steps in the building of a business case that you can communicate effectively to the business. And I'll go through all these in more detail, but aligning with company objectives, benchmarking and proposing ideal outcomes, identifying solutions that support those key outcomes, defining a time-bound proof of concept, tabulating the results of said proof of concept once it's been completed, presenting those findings effectively, and then finally creating the implementation plan and making it real, making it kind of like a concrete thing that the business could do to anybody who might be listening. So let's start with step 1, aligning to company objectives. And I really love this phrase. When building momentum behind a migration project, the best place to start is where the business wants to end, right? And to get that information, that's going talking to people with company objectives. That might be your director of data, that might be your head of analytics. Usually the head of analytics persona is quite tied into what the business is trying to achieve, because they're producing the end result, right? So they're the ones who are getting the requests, getting the questions about here's what the business is actually focused on right now. So here's an example from a company we worked with where the company had one focus. We need to increase upsells in our current customers by 30%. Owner of that was marketing. We're currently at 10%, so we're a good bit behind that. So at this stage, all you're really doing is identifying the problems and where data can potentially help, right? So for example, if anybody requests a change to an account view, it takes 3 weeks to fulfill. So the business can't move with urgency, it can't move fast. If I'm working on an account and I need to go and request something, a change to see a view that maybe I have a call with them tomorrow, it actually takes 3 weeks for me to get the view I need. So that's not fast enough for me to encourage upsells. Dashboard loading time on average takes 8 minutes. So if a dashboard load time takes 8 minutes, more often than not, you won't use that dashboard. And that means I'm going into my upsell conversations uninformed and guessing, rather than actually having an informed position. And disparities across on-prem and cloud data reduces trust in actual account info. So basically, people don't even trust the data anyways. So not only is the data slow in loading, but people don't even trust it when it lands. Okay, so a couple of fundamental issues. The problem is increasing upsells. You can see how data automatically correlates to each one of the issues that people are raising, right? So it's actually quite easy to map those things to propose ideal outcomes, which leads us to step 2, benchmarking and proposing those ideal outcomes. Consider how improvements to data team workflows can improve the issues you've identified. Okay, so in those same examples, account changes take 3 weeks to fulfill. Enable analysts to own transformation workflows and deliver data in 1 week. How do we do that? Well, that's ELT. That's the definition of ELT, right? Once transformation is being done in the warehouse stage, that opens up to a SQL audience, which means anyone who knows SQL can push changes in a much shorter period of time. Okay. Dashboards take on average 8 minutes. That's much more infrastructural. Our on-prem warehousing is slow. Our on-prem pipelines are slow. We want to eliminate redundant systems, and we want to bring in cloud-based technology to speed up those load times. Okay, and then disparities, lack of trust, migrating everything to a cloud solution with routine testing for 100% parity. If you're creating a singular source of truth within a new stack, It's much easier to ensure trust when everyone's getting the same answer to the same questions when they ask the same system. Okay, so you can immediately see how you're taking companies' problems, you're breaking it down into sub-problems, and then you're saying, we can help here, 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 and here by this project, by maybe enabling this project, okay? And we're only at step 2. So this is actually an example of one that I worked with recently, a company that I worked with recently in a migration project, and they had 3 key areas around the issues that they were having within the business. The first, when they surveyed their users, was that people didn't actually trust the data in the first place. That when people went to open a BI dashboard, they maybe trusted the data 50% of the time. So that was something they immediately needed to solve. So they wanted to make their processes transparent and visible. They wanted to make it so people could see how data was moving. They wanted to increase confidence. And they wanted to make it so that every time someone had a request, data products didn't need to be built anew, that they could make reusable objects that could answer a set of questions rather than one question. And then mapping that to the impacts within the business. Decisions are made faster, engineering costs are optimized, better SLAs on platform uptime, happy team. Topic 2 was they wanted to ship data products faster. They recognized that they just weren't able to ship products fast enough to actually keep up with the demand from the business. So they wanted to make it so changes could happen in hours, not days or weeks. Everyone could collaborate across the business, and anyone who knows SQL is proficient in pushing changes. And that would lead to obvious changes, like products are delivered faster to the market. Can we quantify that? Can we quantify the actual value in having a product hitting the market on Feb 1st instead of April 1st? Data team SLA improves, which means higher trust, and development costs are streamlined. And finally, they wanted to reduce the cost of producing insights, right? Every time they tried to go produce insights, there was engineering overhead, there was, of course, infrastructure overhead. They might need to add new warehouses on an on-prem architecture that is expensive. So teams ramping fast because it's just SQL is an obvious impact there. You don't need to teach people, Spark or Python or whatever it might be to try and get involved. Ramping up a new data engineering person is a lot harder than ramping up a SQL analyst at the end of the day. Code is reusable. Cloud data platform costs are optimized. And then obvious impacts related to that around platform spend, development cost, and then data team delivers more and takes pride in the role they play for the actual organization. So that was an example I wanted to share because that was one I really, really liked from a customer that I worked with recently, who kind of really summarized it and broke it down. Okay, step 3 is identifying solutions that then support your key outcomes. So you know what the outcomes are now. You know what you're trying to achieve. What are the solutions available on the market that might actually map to those outcomes that we're trying to achieve? So in those same interviews that I mentioned, switching cost from legacy technology was the #1 reason why data leaders struggled to secure buy-in on migrating analytics workflows. Simply put, the actual migration itself looked like quite a large piece of work, and the teams weren't able to quantify how, one, it mightn't actually be as big as you're considering, but 2, the pros well outweighed the cons of doing this work. So for example, 67% of DBT Cloud users said that enabling non-engineers to absorb more development work has been a top benefit of implementing analytics engineering workflows. Okay, so here's an example of, once again, another business case I was working on about identifying solutions that support key outcomes, right? On the left here, you can see they've identified solutions that can help. Modularity in their code, accessible authoring, built-in version control, documentation of their code, job scheduling, data quality, etc., 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 etc. They've identified these as key areas that will help drive the outcomes that they previously proposed. Here's how it works in today's world in our legacy in-house. Here's how DBT Cloud or the data warehouse or whatever other tool it is you're evaluating can potentially solve those issues. Okay. 4, starting to get into the practical, defining a time-bound proof of concept. Okay, so you know your outcomes, you know the tools that you want to test to do them. Now we need to know, if we were to run a proof of concept with these tools, what that proof of concept look like? And it's got to be quantifiable. It's got to be something that's concrete, and there's a start point and there's an end point, and we know when we're finished with said proof of concept. So should be structured to show demonstrable impact on your key outcomes. You should gather use cases to test these outcomes, and for each consider things like time to perform, cost of context switching, resources required, stakeholders involved, cycles to completion. Why are all these things listed out? Because they're quantifiable. The things that if you run it in stack A and you run it in stack B, you'll get an answer at the end of this is how long it took. And that's what senior stakeholders are going to look for when you're making a comparison. What's the actual quantifiable benefit of doing this? And then design use cases around that. So your use case should be something that happens day to day, should be something that is happening day in, day out, and it's a process that you want to run in both places. A data engineer updates a customer account model to reflect changes in product type definitions. A job model refresh fails midway through the pipeline. Hopefully that one doesn't happen every day, but it will happen. A financial analyst wants to validate the accuracy of an account's ARR. These are things that you can just see happening in the business day in, day out, right? So you want to see how they perform in each individual stack. 5, tabulate your results. It should be relatively easy if you've done step 4 effectively to run both processes in both places and then tabulate and measure the results, because this is what your senior stakeholders are going to look for. You've done the work, you've done the comparison, it's quantifiable. Here's the answer to the question you asked. And you can see here this goes into quite a bit of detail around setting some baselines around stakeholder data delivery time, 3 weeks. We're trying to bring it down to 1 week. Dashboard load time, as we mentioned, 8 minutes. We want to bring that down. We have an ambitious goal of 5 seconds. Quality, support tickets for data validation used to take 10 weeks. We want to bring it down to 1 week. So you can kind of have your overarching goals and then sub goals within them, like number of data marts delivered, number of hours servicing ad hoc requests. This will obviously be specific to your situation, but should give you a good idea of the kind of things you might want to tabulate. Within that tabulation, I like to break it down in 2. Make sure you're mapping to organizational goals. Going back to step 1, make sure you're mapping your tabulate, like what you're recording, to those organizational goals. So risk reduction, 100% of data models now tested prior to production. 40 percentage point reduction in data downtime. So you're actually increasing your data SLA. Growth revenue, 15% increase in speed to market, 20% increase in upsells based off that 15% increase. I won't go through all these. You get the idea. And then this is the one which is going to resonate the most often, because it's going to be 100% the question you're going to get, which is, what are the financial savings? Especially now, right? A little bit of tightness in the market right now. Financial departments within businesses are generally asking any project to quantify the financial benefit of why they're doing what they're doing. So you are going to be asked these questions, and basically every company I work with at the moment, this is something we're working on. What are the costs in your legacy architecture? What are the costs in the new world around annual transformation costs, licensing costs, warehouse costs for infra? Labor costs is something that really needs to be taken into account as well, because if you can optimize your labor costs, that's something that's quantifiable as well. And then you can annualize that. But that is 100% a question that you will be asked as well. So organizational, also financial is important. Okay, step 6, presenting your findings. I've seen this done in numerous different ways, from PowerPoints to Word docs to everything in between. These are just examples of key metrics that I've seen other businesses work on. And these are actually tied to like use cases. So like it can be good to actually bring use cases of the projects having been done before. When you're working with vendors like us or like Infinite Lambda, make sure to ask them for case studies. They always have them. And you can just get examples from other businesses, right? JetBlue reduced maintenance windows from 8 to 0 hours. Firefly Health increased production speed by 20%. These are the kind of metrics which will normally resonate well. Here's an example of a presented finding from a customer I worked with recently around They had 3 goals: unblock more people from accessing data, reduce technical debt within software engineering best practices or with software engineering best practices, and then alleviate data mistrust and drive better business decisions. How DBT Cloud helped, which was what they wanted to move to, and then the business impact. Very clear, very concise. Here's what we were trying to measure, here's how we did it. Finally, create the implementation plan. Now, I think at this stage, when I say create the implementation plan, I think people picture something like this. But for me, when you're at the business case stage, you don't need to be so explicit as to map it out that clearly, right? As like dates and months and weeks and sprints and all that kind of thing. I much more prefer something akin to this at that stage, which is here's what a potential implementation could look like. We need to, scope it out in a little more detail. We need to get buy-in from the business before we go ahead, but we're going to begin our trial. We're going to engage security to do some security reviews. We're going to onboard one team to see how that goes. We're going to plan the transformation migration, implement that transformation, promote those transformations to production, et cetera, et cetera, et cetera, et cetera. So like high level, I guess is the point I'm making rather than diving deep on specific weeks and sprints. Okay, is that that was my last bit. So this is all in an ebook, which I can share within the chat if people are interested. But I think maybe people will be very interested by the next bit, which is digging into the actual implementation itself. So Sammy, I'll pass to you.
Brilliant. Thanks, Mike. Great. So now that we have learned how to structure our use case, I think it's a pretty good segue, going into actual implementation tips and how to actually do the migration and useful, valuable tips that we've learned working on this project. Just before I start, just a few words on Infinite Lambda. So we are a global data consultancy and academy, and helping businesses across the world becoming more data driven and driving more values out of their data. So we design strategies, implement solutions, but also train engineers to drive sustainable change at our clients. We have a lot of certified engineers in DBT, technologies like DBT, of course, but also Snowflake, Fivetran, GCP. And we are a premier DBT Labs partner. We've done a lot of migration projects, over 60 of them. So we have accumulated quite a lot of experience in that area. And also we were named DBT Partner of the Year for EMEA last year, which we're really proud of. So what I want to do with this session is really share with you guys valuable lessons that I personally have learned whilst working on migration. And the way I want to structure this is to go through a little bit like Mike did for his presentation, is go through chronologically and starting with the planning phase and then going into the actual implementation and the challenges that you may come across during your implementation. And finally, once you've got your new fresh DBT setup, how do you make the most out of it, and how can you drive the most value out of? I have seen some questions already in the chat, and I think some of what I will say will answer that. But of course, I will leave some questions at the end to go through any questions that you may have. So first of all, I guess one of the best advice I can give you is obviously plan for your migration. Now, what that means? Well, first of all, had to put a few memes in there just to because it's what we do these days, I guess. So the first tip is to plan your migration, and I like how Mike was talking about tabulation and putting everything into a simple table. Well, it is pretty much the same for the migration, and I've seen a question around what order should you tackle things when you do your migration. Well, this is the point that I'm trying to to make here is before you start, it's very important to build a picture as precise as possible of the content that you need to migrate. And usually this is going to be a set of SQL files, views or stored procedures that you want to DBT. Now, before actually going into the details, one caveat here is most of my examples here are based off of a migration project, which is actually a little unusual because it is a migration from SQL Server to SQL Server, but DBT on SQL Server. Now, unusual because usually when people, I would say, upgrade their data warehouse, they choose modern data warehouses like Snowflake, GCP, Synapse, Databricks. But as also Mike mentioned, in current market conditions, some companies just decide to do a small step into the cloud first, just as a sort of a big POC. So trying to limit the cost and invest in a limited manner to see what benefits they get. So the latest project that I worked on was that. So a DBT migration from SQL Server to SQL Server. But that in itself is obviously a valid move, and that can bring a lot of benefits. Now, going back into this topic. So the idea here is to try to gather as much information from the content that you need to migrate, and focusing on trying to understand how complex these views are to migrate. So some of them are very simple. Some of them are more complex. And the complexity comes from, for example, some views having platform-specific SQL bits of SQL dialect, or obviously a lot of logic, a lot of nested logic. So this is the sort of thing that you want to gather. Now, you can do this manually, but ideally, you want to automate this and create some sort of tooling that will output a table, such as this one, that you can use to organize the work of your team. So at Infinite Lambda, we have worked on a couple of these toolings, sort of accelerators, that focus on extracting this information from the existing code base. So that can be an SSIS set of packages, that can be just a set of plain SQL files. And the idea is to just try to extract information so that then you have your plan. Now, that is one thing that you want to measure is the complexity. But you also want to have a priority list of the order into which you want to tackle these files. And that addresses one of the questions that I've seen in the list of questions. And that is that, like in DBT, you have your very valuable lineage graph, right, which shows you which model depends on which model. But when you do a migration, you don't really have that. You just have a set of views. Sometimes they are well organized into folders, but sometimes you don't really know. So the idea is to try to build that dependency graph into this table so that then you have almost like a plan already for your team, so that you can decide which mass you want to tackle first. Usually these are going to be your sources and then your staging models. And then once you have your first layer, your staging layer, you move on to the next layer, your intermediate layer, for example, where you have your transformations. And finally, you would build your mass. You couldn't, for example, start with a mass because you wouldn't have the models on which those depend, right? So the idea here is to avoid these traps by doing things in the wrong order and gather as much information as possible before you actually start typing anything into your, on the keyboard. So I say measure twice, cut once, because it's a bit like DIY, where, if you don't do your measuring before and you cut, then, well, you need to do it again. So this is, I say, like one of the general tips that apply here to migrations. And something that I've put in here is that, so something to expect when you do a migration is that the projects that you're going to be migrating are projects that have been built sometimes over many years. So one trap, I would say, is to say, hey, I've got 100 models to migrate, and I've seen a couple of them, and they're pretty simple. So I'd say 1 hour per model, and then do a sort of linear extrapolation of this and come up with like an estimation. Sometimes this isn't actually accurate because there's a lot of variability in the complexity of these models. These have been built by different people, different teams across the years. So it's very important to spend some time and really assess the complexity of what you've got, what you're working with. Second tip, which is how do you actually go ahead, with organizing the work and sort of how do you manage the work of your team. So this is perhaps more relevant for the consultants here in the audience today, less so perhaps than just product team doing their own migration. So this is an example of doing a migration and then everyone in the team starts at the same time. So you have data engineers and analytics engineers starting at the same time. Now, usually you would prefer having data engineers first, but this isn't always the case. So the tip that I usually give to data engineers working with analytics engineers is, well, these guys are here, so you need to give them data to work with. And what you want to avoid is analytics engineers sitting around for a long time without having data to work with. So I think one valid strategy as a data engineer is to first make the data available to analytics engineers, whether that means creating some very simple load pipelines. And once the data is there, then you can go away and work on those pipelines to make them, for example, incremental, more performant, tune them. But the idea is to just have this approach of being able to work in parallel, which means enabling the analytics engineers, and then whilst they are starting to initialize the DBT project and starting building the views, then you can go back to data engineering work and make it more performant. So then tip number 3 is also, when you are planning for your migration, you've got to know roughly what options are ahead of you in terms of tackling the work. So you've got pretty much 3 different things that you can do with code. So one of them is lift and shift, and refactor and remodel. Now, you may have guessed, you go here from left to right. Here is from most simple to more complex. And essentially, lift and shift is pretty much when the code base is already almost ready to be transformed into DBT code, and you just need to do a little bit of copy pasting. So that is obviously ideal. Some of your models that you need to migrate will be like this, but usually not all of them. And then refactor and remodel. Refactor is when it's pretty much there, but you do need to move a few things around to make it a little bit more DBT-like. But overall, the layers and the overall structure of the code is sound. Now, remodel, and that can happen, is sometimes where, well, for example, I've seen projects where the whole project is in a single file. That can happen. And, that's sometimes how people build these things, and because they work, they are maintained in that way. But this is a case where you need to do a little bit more thinking around restructuring the code and lifting some things out and moving them into different places so that your DBT model can work best. So those are your three options, and I'm going to go into examples of each of them. But one thing you have to be aware of is that this is your final strategy. Likely will be a blend of these 3. So usually don't expect the whole project to be one of, but you have to think about also, when you're doing your planning of the models you have to migrate, which model is going to be more a 1, or a mix of 1 and 2, or 2 and 3, etc. So yeah, just going through and a little bit more into details here. Lift and shift. So you have here, on the top you have your view that you need to migrate. And you see that in DBT, the change to a DBT model is very simple. You just remove the first line, and then you replace the reference to the table by with a ref function. So this is a best case scenario where you don't have to change much. Refactoring is when you have view. So again, here I'm giving, those aren't really real examples, but they just illustrate a point. So here you have a query where a lot of things happen. So, and usually it's best to lift some of the logic into CTEs to make the logic a little bit more understandable. So, this is the case where you have the layers are well structured, but you need to rewrite a little bit the code into CTEs to improve the readability and improve the clarity of the logic. And then remodeling is, in this case, you see you have one file, and actually what you want to do is lift that into 4 files. So this is a bit extreme here because obviously on the left, you could almost work with that. But what I'm saying is sometimes you want to be able to split the logic into different files because, and that's something that Mike also mentioned earlier, is making things reusable, right? And this is where you're going to make your project better when you have order data, customer data that need to be used by other models. You need to, if you lift them into a specific model, then these can be reused. So this is making your code base more modular, so that bits of logic can be reused across the project, and that is very important. And that's one of the things that make DBT, a great tool, and will make it much easier to debug and develop further models. So you've got your plan, you've run your automated tool to measure complexity, and now you're in the project, you've started the project. Now things are going to come up, that's for sure. As consultants, I suppose you've got to expect things to pop up, right? You can't just expect things to go smoothly. I mean, I think obviously DBT works really well, but there's always going to be some difficulties. So here I'm sharing some of the problems that I've seen in the project that I've worked with. So, and there's always a way, usually almost always a way to resolve them with DBT. So in the case of SQL Server, things that you could see is projects that rely a lot on auto increment IDs. So what is an auto increment ID? Well, it's an ID that auto increments pretty much. So you insert records into a table, and then you've got an ID that goes 1, 2, 3, 4, and that gives you a unique key. Now, this is very useful in SQL Server because it's a nice feature, but in DBT, it doesn't really exist. And the problem is then, if you don't have this key, you need to find if you do need a unique key, which is usually the case when you do joins, you need to find the granularity in the rest of the columns. So you need to create surrogate keys. Now, DBT offers you tooling to do that, which is great. But you will need input from the business team to give you knowledge into what columns you can use to get your unicity. Because if you use a lot of columns, then your models will be less performant because the hashing of a lot of columns will be more heavy on the engine. So you need to just need to rely on your client in some cases, or just have some knowledge of the business knowledge to know how to form your keys. Now, time version tables is another example, a very much loved feature in SQL Server, which is sadly not a materialization in DBT, but DBT has got DBT snapshots, which is exactly the same thing. Now, sometimes it takes a little bit of time to explain to your client that those are exactly the same thing because they don't have the same name. But it's one of these cases where DBT actually has the materialization that is very close to what you want to do. Now, data collation, another example of problems that you can have when you typically have snapshots that you migrate. So the problem with the snapshots is that you need to maintain the history. So you're going to have the history, let's say, from long ago to the start of the migration that comes from SQL Server, and then your snapshot is going to go from that onwards. And you need to combine these two. However, SQL Server has this thing called collation, and when you union or join data with different collation settings, then you get problems. So fortunately, you can actually specify collation changes within your logic, within your SQL code, or you can just use a one-off script to that. So one of these issues that thankfully has a nice solution. Now, another point to, I guess, useful point is that as you are going through your migration, you can actually use DBT to ensure that you are the quality of the migration. So it's quite typical that an engineer, pardon me, an engineer will develop models in DBT and then switch, for example, to Azure Data Studio or Data Grip or whatever to run to check the model is has been created or is has got the same number of rows as the old model. But you don't need to leave DBT to do that. You can just use DBT test, right? And this is an example here of using DBT test to assert that the set of keys that you have used for your surrogate keys are actually unique, right? So there's a test for that, so checking the unicity of the combination of columns. And you can actually use other features to compare. So there's also the DBT audit helper that can enable you to compare different tables and make sure that while you've migrated, as part of the reconciliation, you can check that the work that you've produced actually, matches up with the source. So remember to use DBT not only to power the new platform, but also to help you whilst you are doing the migration, because it has great features for that. Now, another issue that you may come up with is hard deletes. So especially when you migrate away from a legacy stack, you might have sources that gives you a hard delete. Now, what is a hard delete is, well, when the source just deletes the record, instead of flagging it as updated, as deleted, sorry, which is a soft delete. And actually a soft delete is an update. A hard delete is the record is gone. So the next time your ELT, your extraction pipeline runs, it will simply not see the records. But if you have incremental models in DBT, well, these models will not know that the record doesn't exist. And that can be a problem where you need to track this behavior, or you have a count in a mart, and some of the records that make up this count are actually gone. So ideally, you want to source with soft delete. It's easier. DBT prefers that. Now, DBT still offers you a way to deal with those, and this is an example of a bit of code that I really like that a colleague of mine wrote, which is using post hooks, where you, as part of your incremental model, you select your source, so that has the source records, so that does not have the deleted records. You select the source in your current model, and those have the models that have now been deleted, right? And you left join it to the source to essentially flag those records that are no longer there as deleted. You union that, and then you give it to the merge, right? And that merges it. And then after this, you have a bunch of records which are now soft deleted, and those you can remove with a delete. So it looks like a lot, but it's actually quite simple to understand when you go through it, and it's very useful. So again, no panic if you have a hard delete. DBT can help you with it, which is good, which is great news. Now, orchestration. Another, and I've seen this into the question is, okay, DBT Cloud is great, absolutely, but not all companies can or want DBT Cloud for different reasons. I've worked with companies where it was, they didn't have the budget for it. So if you have DBT Cloud, by all means, it's a great orchestrator. It's really good. But if you don't, again, you need to budget for some additional effort as part of your migration to provision some specific architecture to run DBT, because you've got DBT, you've got your DBT project, developers are running it on their schemas, but how are you going to be running it, in the cloud and on a schedule? Well, you need something. So at Infinite Lambda, we have used this architecture, which is really nice, which is using Data Factory as an orchestrator. And then DBT actually runs on Azure DevOps agent, which is kind of like GitLab runners, just little VMs that, the good thing with DBT is it doesn't consume a lot of CPU on the machine, because DBT just sends instructions to your warehouse, right? So you just need a light box that comes up, runs DBT, gathers the logs, and then pushes them into a storage where you can then visualize them. So we have developed this pattern using Data Factory, where Data Factory triggers the run, pulls the API to monitor what's going on, and then reports the results. So it's I can share that, and we will share this as part of an article later this month, I hope, or next month. Right, just getting to the last part here. So in terms of now using the DBT, so I would say how to make the most of DBT, right? Is well to use it, right? To use it, so make sure the team uses it, the new flow around pull requests and pushing new codes to the repo, getting that sort of collaborative groove going, which wasn't the case before, because people used to just update the code, sometimes directly in Sublime Text, and then push it into SSMS, stuff like that. So getting used to that new rhythm, integrate with your work item management like Azure DevOps or Jira, like get those integrations going that are going to make your team really productive. And then use the DBT docs, right, to drive awareness of, well, now we can do all this stuff. We can test. We have all these assumptions on the data. So, distribute, get that message across using the DBT out of the box features. And then, well, I would say that once you've migrated, sometimes you haven't made use of all the features. So there's plenty of other features that you can start using once you've completed your migration, right? So you can have different runs using selectors. You can tag your models and have different runs that that target a specific subset of your models. So you can have higher frequency runs for certain models, right? And then you have the snapshots, the seed. So you have all these other features that you can start using once you're now in a DBT world. So you have access to all these wonderful new features. And that's just a start, right? You've got analysis, semantic layers, etc. So you can then start really playing around with DBT. And I would say that, yeah, again, this is just the beginning, right? So there's always new ways to improve your DBT installation. You can play with SlimCI to only test the models that you've modified as part of a change. You can always remodel, and of course, you're now completely separate from the SQL engine, right? So in the case of the project I worked on, once the code is in DBT, well, it's now easier to move to Snowflake because the code is mostly independent from the platform. So there's sky's the limit as to where they can go next and the efficiencies that they can get. Right. So thank you so much. This is it. So I think there's a few questions. Okay. I think Mike, you've been busy replying to some of these already, so that's good.
Okay, can you hear me?
Yeah.
Sorry, I think my internet went down there. I just saved one here that I thought you might want to answer live. Was from Peo. Lift and shift aside, there could be significant deviations from the original setup. How do I keep track of a changing tech context for my project, and how involved do I need to be if I get external help with the migration? So I don't know if you want to take that one.
Yeah, sure. Okay. So let's just reread the question just to make sure. Yeah. So absolutely, it's actually a great question because if you don't do a pure lift and shift, as you say, you're gonna end up with deviation. So yeah, it's very important that you indeed keep track, have a decision log of all the decisions that you've made, because you will need to make a lot of decisions because it's more important to build a healthy DBT project rather than one that really sticks to what you had before, because the likelihood is the new project will be a DBT native project rather than a SQL Server project that has been migrated to DBT. So in terms of how do I keep track, you keep track essentially. You just log these decisions and you just do it that way. In terms of how involved do you need to be? Well, I think it's actually a great question. You do need to be quite involved. I think Mike is gone. So you do need to be involved in this project. It's actually something you need to budget for, as in on top of just being present. If it's something that you're working with consultants to do this migration, you also need to give a lot of your time to make sure that you stay on top of that context. So I would say, how involved do you need to be? Very, because it is your project, it is your baby. And even if you're working with external consultants, external specialists, they will need you to provide your business knowledge, and you will need to stay on top again of this changing context. So yeah, that is a very good question. Okay, so I think Mike is gone. He did tell me that there was some harsh weather in Ireland. So I think that's probably his connection has dropped. So let me have a look at other questions. And so I saw one about so there's the SaaS versus DBT Cloud, and yes, Mike's answered that. So you can obviously still very much use DBT Core, and you can orchestrate that using different methods. Okay, so I will take this. So in terms of the resources, so DBT has the DBT itself, the website has got a lot of great resources. In terms of basic training, I actually recommend that as a preparation for the exam, if you want to take the exam. So it's a bunch of DBT folks walking you through different aspects of DBT. So this is really well done. So I really recommend starting with this if you can, and it's free, so even better. Okay, so how to keep a copy of the legacy code or this pipeline? Well, I suppose it depends. You can keep it. I mean, you will certainly, whilst you do the migration, you will certainly need that code. Your developers will need the code to create the new DBT model, so you can actually keep that in a repo somewhere. You will actually probably keep it running, doing some dual run for a while. So a lot of people do that. Once you to get a good confidence that the new platform and the old platform provide similar results. So I would say yes, you probably hold on to it, and then I think naturally, you can keep that code as reference, but naturally you will archive that repo and focus on the new code base eventually. Okay, I've been going to this. Do you think old ETL style have still some relevant use case? Well, I think it depends on it depends. It depends on the stack that you are using. I think today, if you are working with data warehouse like Snowflake, GCP, I think it really drives you towards adopting ELT because you've got so much capabilities and on the Snowflake side, right? That it almost you kind of have to make the most of these features. But if your destination is a legacy database, then that makes sense, right? So I suppose it depends, and you can sometimes, and it's the case of the project I've worked on, where DBT is introduced within an architecture that is still kind of legacy. So you can what we call sort of a hybrid architecture. You've got a little bit of the new modern data stack, but a lot of also more legacy tooling. So I would say that yes, it very much so. There's very much relevant use cases for old, not that old, but a little bit old ETL, because there are a lot of companies that are still maintaining who can't necessarily afford a full refurbishment of their platform and just going full, doing really significant investment into a new stack. So I think the new model offers a lot more comfort, right? In terms of the schema change, management, and just scalability and all of these advantages that Mike mentioned. But there will always be, as long as some people still rely on them, there will still be relevant use cases for these more legacy bits of architecture. Okay, so how do you estimate the complexity of refactoring legacy code? What do you do if it turns out it takes out more time? How do you best communicate this delay to stakeholders? So it's a great question. And in terms of estimating the complexity, so you can either just do it by hand, but if you've got a lot of material to migrate, then it might be worth using an accelerator. So as I mentioned, at Lambda, we have created some of this tooling where it's like a Python solution that will go into the code and try to identify things that are going to make it a little bit more difficult to migrate, such as, hey, this SQL word does not exist in Snowflake or does not exist wherever you're migrating. So you're going to need to find something that, you can't just replace it or remove it. It's not going to work. So looking for these things. And then other things are very simple, just like number of rows, number of joins, right? So for example, if you are moving away from auto increment IDs to surrogate keys, then you're going to need to go through every join. So, a model that has 100 joins will be much longer to process than another one, because you're going to need to go and check each of them. Things like joining between different layers. So if you have a project that joins a mart with a staging model, right? Those models might not have the same set of keys, or the keys might not have been hashed. So, this sort of, and obviously you can go very much into the detail, but you realize on the ground when you do this project that even just simple bits of information can really help your team. So I would say just have a sensible approach of what you think makes it difficult to migrate, and then just try to automate that. And in terms of it taking longer, this is where I'm talking about the person or the team requesting the migration to be present and providing some of their time, because it's very important to keep them on track, so that they're aware of the decisions that have been taken, the challenges, because indeed the initial estimation might evolve quite a lot from when the work was initially estimated. So it's very important to keep the communication going and be transparent with your team. Okay, well, guys, we've answered quite a few questions. It's 10 past, so we've run over a little bit. I think I will give this maybe a few more minutes if you have any more questions. And yeah, the recordings will be shared. Yes, I know Mike mentioned that at the beginning. So yeah, don't worry, the recordings will be shared. Okay, great. So guys, thank you very much for your attention and for all your questions. We will distribute the recording, but in the meantime, I wish you a lovely afternoon. Thanks again for your attention, and we will see you guys soon. Good luck with your migrations. Bye-bye.